We're all familiar with drones. Also known as UAVs, unmanned aerial vehicles, drones are now used across various sectors, from military operations and agriculture to entertainment. There are several types of drones, including fixed-wing, single-rotor, and multi-rotor systems, such as the quadcopter. In this video, we'll explore the basic physics behind the quadcopter and how it is able to fly. A quadcopter is a type of drone that uses 4 motors, each equipped with a propeller. To lift off the ground, a quadcopter spins all 4 propellers to generate upward thrust. This is based on Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. In the case of a quadcopter, each propeller pushes air downward, resulting in an upward reactive force that lifts the drone. However, this lift must be balanced with the drone's weight. If the thrust is less than the drone's weight, it won't take off. If it's too much, the drone will climb too high too quickly. Importantly, not all 4 propellers spin in the same direction. Instead, 2 spin clockwise, while the other 2 spin counterclockwise. This is done deliberately to cancel out the torque that each propeller generates. If all propellers were to spin in the same direction, the drone would begin rotating uncontrollably in the opposite direction due to unbalanced torque. To maneuver, the drone utilizes 3 rotational motions: pitch, roll, and yaw. Pitch is the rotational movement in the y-axis that causes the drone to tilt forward or backward. Roll is the rotational movement in the x-axis that causes the drone to tilt sideways. And yaw is the rotation in the z-axis that determines which direction the drone is facing. To move forward, the drone slows down the front propeller and accelerates the rear propeller, so the drone will tilt forward. If we analyze, now the propellers are not only pushing upwards, but also forwards. That is what causes the drone to move forward. Conversely, for backward movement, the drone accelerates the front propeller and slows down the rear propeller. Likewise for motion to the right and left. Then, how to adjust the drone's facing direction? The answer is to rely on the torque effect. As we discussed earlier, drones use propellers in opposite directions to prevent the reaction force that causes the drone to rotate. So, to turn the drones facing clockwise, we can speed up the counterclockwise rotating propeller and slow down the clockwise propeller. That will make the drone rotate right clockwise. Now we know that in order to fly and maneuver, drones rely heavily on physics concepts, especially Newton's third law. If you found this video useful, don't forget to click the subscribe and like buttons to support our channel. Thank you and see you.